Hi, good evening, everyone. Today, in this session, in this webinar, we will talk about mechanical engineering. In that, mainly about automotive sector. What are all opportunities we have in the automotive sector, and also how can we align our career through that. So, before starting that, let me introduce myself. I'm Sunita Namboru. I have 15 years of experience in FEM, mainly in analysis and simulation. I'm a postgraduate from IIT Madras, certified Six Sigma holder, which is very much required for an mechanical graduate to understand how the system is working. Also, I hold a patent on structural analysis. This is for a checking purpose, like how we have done the model. Through this tool, we can do it is like a doctor for any type of the model what we are doing in the tool. So I achieved 15 plus awards in terms of cost savings and for completing the successful project completion and also as a best employee. So had 6 research papers published, and also I participated in 5 plus national and international conferences, not only in my education, even after that in the office as well. Okay, coming to the topic today, what is automotive industry? What the sense it is called automotive industry? First, understand it. For all the companies and activities which belong to the motor vehicles, including the components, that means how the strength of the component and everything. So here you can see that excluding tires, batteries, and fuel. That means whatever the engine might be, either it is a car, bike, or a heavy engineering procliner or whatever, the parts of the different engines and the parts of different things, whatever we have to analyze that. So that is nothing but it belongs to automotive industry. Okay. So now you might have understand the spread of it. That means to what extent the automotive industry is expanded to. Let us see in this session in the complete details of how many parts will be there, how much of scope we have, and what are the different tools used for the automotive industry. Okay. So you can see here it is a broad range of organization and companies which starting from designing, developing, that means simulation, production, marketing, sales, everything belongs to this automotive industry. If you see, we belongs to design, development. If we are interested in, then we can be a combination of technical and marketing and manufacturing. For manufacturing, how the process is, everything nowadays it is doing not through experiment, it is happening through these simulation tools which will reduce our time and cost effectiveness. Other than this, we have so many other things also, like in terms of simulation and design and marketing. So in terms of maintenance and services, then which an automotive tool will provide everything. So to give in some other, in more sense, you can see it is a unique and challenging career who is passionate about regardless of skill level. That means according to our skill, according to our capability, we can choose in which we have to go. As we are saying that automotive has wide range, broad range of uh, simulations or design we do according to our skill level and according to our interest, we have to go for the specified part or specified stream to say. The picture you can see here, it is talking about aerodynamics, design, simulation. In simulation, again, we'll have so many things like strength, durability, safety, and how it is acting. So it is a combination of so many parts. As a mechanical engineer, we'll focus on 80% or 90% of the parts. Other 10% you can see for the glasses, or for the external architectural purpose. And also these days we are getting AI built systems also in the car. That means that portion it is related to software with the combination of mechanical inputs. So that means we can go here as well. Okay, so two, who can go to automotive industry? Who has high standard of professionalism, a passion for learning, and enthusiasm. Why to choose this industry? It offers job security because you can see day to day and every year how many new vehicles are launched, either in terms of car or other segment SUVs, motorbikes, and even procliner kind of things. So that's why job safety is very high and positive career outlook. Why it is also we will discuss. And automotive industry offers versatile. That means each part, how many parts you will be surprised like these many parts are there in the industry. So there were so many parts, so many kinds of tests we are going to do, so many designs we are going to do in our models. So for that, it is broadly expanded and versatile, offers personal and career growth. As you are passionate about it, it will be always interesting to see the parts, how it is working in natural scenario, for which we are doing design, right? The automotive industry offers good salaries. You may think that IT is going good, but not. See, if we are capable of earning, have a good basic knowledge and what we have to choose our career according to that, we have to upgrade ourselves. Then, compared to IT, mechanical industries pays high too. So has bright future, and we can say that king of future is automotive industry because it is expanding a lot. Mainly we can find lots and lots of manufacturing units, and in terms of design and in terms of simulation even in India as well. The top in the world is Germany. Next to that, India is the next, where we are building a big empire on automotive industry. So you can see some insights here. This is based on the India statistics. Growing demand is very high. In 1 year, how many billions of units it got sold? That means you can see how many billions means it is a vast range of vehicles. That to passenger vehicles only they have mentioned. Vast range of vehicles. If it is vast range of vehicles means we have to make those many designs in different vehicles. Okay, those many designs needs those many testing units, those many manufacturing power, and so many. Everything is interlinked. Okay, so now you can see the roadmap to launch more and more industries, that too in automotive. Factories or industries is also there in our India, mainly Chennai based. So that's why you can see most of the companies of manufacturing companies are in Chennai or in Pune. Okay. Companies, you can see raising investment in terms of Indian market as well. And we have so much of opportunities in the next coming 8 to 10 years where we can build. And one more another point to add is, now everybody knows that there is a lot moving towards battery system. If they are moving towards the electrical cars, there also so many parts we have to redesign according to our Indian roads and according to our terrain conditions. So many structural components we need to design from scratch, as it is from for a different fuel like battery. So where weight optimization, like, so as the weight increases, fuel efficiency decreases. With compatibly, we have to manage the weight and the fuel efficiency in terms of battery and everything. So then we will get high performance or high quality vehicles, for which opportunities are more for mechanical engineering, that too in automotive industry vast. Okay, then you can see some of the parts I have listed here. You can see if you by picture only, there were about more than 1,000 parts we can see. So each part will be of different material. Each part functionality is different. As a part we have to design. As a sub-assembly we have to design, and as a complete assembly also we have to design the total for the safety purpose or the strength or durability. So some are listed here like engine parts, interior components. If we say as interior components, then you can see as suspension modules. In that again, you can see the assembly of the suspension module. For example, I'm going to give here, if you take a suspension module, definitely spring will be there, right? So design of the spring, optimization of the spring, material in terms of material, in terms of shape, and in terms of flexibility. So for a simple spring, these many analysis we will do to know the strength as per the functionality. When we are coming to the assembly, spring with a suspension rod, then you can see how it is acting. The dynamics of this functionality of the spring we need to check. So in out of 1,000 plus parts, I have given only one example, which is showing like how much time we need to spend on it. Okay, in the same way, interiors in the sense other than foam or something, even those seat structures should follow on a frame. That frame will carry the load, not the foam or the seat, right? We have to design that frame according to the weight, what we are putting on the seat, on the backward, and how the system should design. And the seat, clutch, brake assembly, and so on. So many components are there. Individually also we'll throw some light. Before that, we will discuss how many types of the categories globally we need to do for any automotive industry. So the major things I have noted here. We have to do for the body, and then the chassis. These and all the designs of the structural component we can say. These are the design of the structural components like interior. So in that again, if we take body, in that about 20 to 30 sub components will be there. Some structural examples I have given so that you will get a sense like what are all designs we are going to do for an automotive industry. Okay. And also in later stages, I will explain you how we have to decide whether in which tool I have to design, and how according to different analysis which tools are available in the market, how should I go through it. So whenever you have questions, please type in the chat box. I'll be happy to answer those. Whatever questions you have, anytime you can stop me and ask. Then according to the performance, what are all simulations we are going to do? NVH, that is to find noise, vibration, harshness. If I take an example of noise, then you can see I have to check for the road noise and wind outside the road, how it is happening, that, and so many inside, if anything machinery we are accessing, how that noise is happening. So, and then how the sounds are affecting internally. This is the best example. Always we feel that noise from outside should be less. To understand, I'll say of day-to-day example, you can see in our home also, the walls will absorb the noise and it will release only less noise inside the home. In the same way, we will be doing different types of analysis to reduce the noise inside a automotive vehicle, for example, car, you can say. Okay, so how it is taking the wind noise, that means wind through air, how it is taking, all those things also we will consider. Vibration because of the air, because of engine parts moving, and of weight. Different portions we are going to analyze vibration based on the component wise, sub-component wise, based on the simulation. That means based on the running operating condition wise. Like that, we will be doing for each thing a vast, again, if you take each subject, it is a vast ocean kind of thing. Then aerodynamics and thermal. How can we reduce drag? So any car has to move fast with less fuel consumption. That will happen by reducing the drag. If you observe the cars of sedan cars, you can see you can reduce the drag and it will form in higher speed. That is why we have to consider the aerodynamic and also thermal change. It is in the cold temperatures or it is in high temperatures. Then vehicle dynamics we are going to talk about. Vehicle dynamics means how the components are attached and how the simulation are going to happen. You can see that front tires and back tires, how it got attached. Okay, so how the dynamics will happen? That will happen definitely through a gear system. Okay, how the dynamics through when we are moving, when we are turning a vehicle, we should observe that if both the tires are running with the same speed, the turning won't happen. For that, there should have an gear system in between the two tires, which will place or which will helps to rotate or turn the system. Okay, so that is how we are going to do that is through vehicle dynamics. Then safety. This is must thing in vehicles, that we have to find the safety of a car while when a lorry is touching the car, or if we are dashing to a divider or a pole, different scenarios we have to understand to know the safety. Even though the car is getting damaged, the inside people should not get affected much. Okay, that's why they are making the airbags and all. Okay, these are different simulation areas where we are going to address for the certification or for the manufacturing of a automotive system, to say in terms of performance. Now let us take component based on the models. That means you can see how many models are there for single component. If we take a body in white components, you can say that means my car body, how many subcomponents are there which will get attached to everything to form a global assembly of these things. So I mean, most of you might be knowing that most of the body in white components are of composites, and you have to do, since it is a thin shell model, so most of the times we will go for, this is very thin sheet kind of models, we will go for shell elements which will help us to simulate as per the real scenario. That means the functionality of shell is nothing but we can create any 3D models of 2D shape by using 2D elements. So in that sense, for most of the body in white, we will be doing shell elements. And you can see for one this frame, you have so many, about 15 to 20 components are there. For each and every component, we have to find the strength, durability, failure, fraction, everything for before going to manufacturing. So then you can see that, so how much it got expanded. If you take one component, one car, these many are there. Then imagine how many opportunities you will have in this automotive industry. Let us talk about engine parts then. So some of the parts I'm mentioning here, like engine block, exhaust manifold, in cylinder head cover, and you also observe that some gaskets are made, that is to reduce the damping effect or to reduce the vibration in the system. So oil pan, shift pulley, and so many small parts are there. Each need to be analyzed separately to know its strength based on the functionality. All this we are analyzing separately, and as an assembly, we may be considering some of the components as defeatured, or like this complete assembly to run, it will take very high time and very complex to do. That's why every time, not only in automotive, if for any industry in the other sense, we will be considering this as per the part wise, and also complete assembly how the functionality is working. Okay, here also one example I'm going to give. If we take engine block, we need to at least make 7 to 8 types of analysis for the engine block. Okay, when I'm going to explain about the type of analysis, at that time I'll take the same example and explain you like why we need to do different type of analysis for a single portion, what is the necessary of it. Then structural components other than this car body are the engine. We have these many structural components. Okay, these parts are mentioned and given to you so that it will give a good insight like how much the automotive industry is expanded. For each part, at least a team will be working from from design to manufacturing, from concept design to manufacturing in other sense. For all these parts, what are the types of analysis we are going to do? Here we'll see. Some of the types I'm mentioning here. Types of analysis. Linear, that is the basic analysis to carry forward any part in that sense. And then we have these many types. I'm giving a rough idea of contact, aerodynamics, and so many other things are there. Thermal, nonlinear, fatigue, durability, stiffness, optimization, crash, vibration. So it doesn't mean that for each and every part, all types we are going to do. Only some I have mentioned here. Still, there were so many other types are also there. So if you take a component like engine block, we need to do linear analysis. Since it is an engine block which will be having high pressures and temperatures, we are going to do thermal analysis. Then according to the speed, according to the running time, the load in the engine block, that means temperatures, pressures will vary, right? So for that, we are going to do fatigue analysis, transient analysis, and to know how stiff it is, we have to do stiffness analysis to optimize the part for a new material or for manufacturing part. We have to do that as well. And since it is having high temperatures and pressures, if it is crossing beyond the yield, what will happen? So we have to do fatigue also for that. So for one engine part, one engine block, which is a part of engine, we are doing about 10 kinds of analysis for the certification. Why we have to do? So to explain this, I'll give a simple example. Everybody might have done UTM, right? Universal testing mission, where we are going to extract stress strain curve. In that, when we are applying load on both the sides, we will be having the fracture in the middle mostly. Okay, so if we need to do same in the simulation, at least 3 to 4 type of analysis we need to do, because until the cross section is not changing, it will become linear. Once the cross section is changing, it will become non-linear in terms of geometry, right? In terms of geometry and in terms of material also, because the molecules are getting narrowed down at the force affected region. So once the crack got initiated, then we have to find fatigue. To what extent, if we are pulling, it will fail. So to once it is getting separated, then we have to do fracture. To do that, we have to make fracture. That means single model according to the functionality, according to the physics applying the load, uh, the types of analysis varies. Okay, since we are trying to simulate the actual scenarios. So that is how for one single part we need to do several analysis, depends on the working system of the part. If you have any questions in the part, like what to do, you can ask me. So like that, this is one of the example. Another example also I'm going to give. We have to analyze for the drag system in the car, so that as when we are moving forward, some of the air will pull us back. If the drag is very worse, then acceleration we have to increase a lot, okay, to move forward. So at back of the section, like that means, so how we have to address that, by optimizing the shape of the car, the drag should be less. Okay, that will happen through aerodynamics, aerodynamic analysis. Is it clear? Do you want me to give another example, guys? I think it's clear enough. Then what are the steps for simulation? Irrespective of any type of analysis, these are the steps. We have to do CAD, that is design, and then mesh, that is nothing but meshing tool or any simulation tool, and then assembly. Boundary conditions, we have to apply as per the component and as per the functionality of the component how we are making. Okay, compute the results, analyze and test it. Okay, so these are the steps. Irrespective of any of the type of analysis, these are the steps. But based on the type of analysis, geometry will vary to little extent. Mesh, according to the type of analysis, mesh factors will remain different. For example, for static condition, one type of mesh I need. For model analysis, I need another type, where we are going to analyze the vibrations and all those things. If it is a single component of an assembly, if we are making for a bigger components of like this car, complete vehicle, then so much we are going to assume, like, so the thick parts or straight parts we will make as a 1D element, the sheet element, and also 3D sum parts. It depends on the structure we are considering and type of analysis. The factors will vary, but the process will remain same. Boundary conditions are also different. So if we are taking only engine block, we may need to fix on the bottom side. If we are taking the complete engine body also, we will be fixing bottom side where it is attached to the part in the car. Okay. So how we are going to make the assumptions and all those things, it will be available in our course, which cannot be explained in 30 minutes or 40 minutes. We have to have a proper procedure how we have to analyze for CAD, mesh and vehicle dynamics too. Okay. Then now coming to the actual scenario, generally in industries, what are the tools they will be using for different types of designing or simulation based on the analysis type and design. So you can see for design, majorly in any automobile industry, they will use SolidWorks mostly, or they'll go for CATIA. Each will produce different. It depends on, now you may get a doubt like on what basis they are going to decide about the tool. It depends on the size of the company and legacy what they were using, because SolidWorks just happened to come just before 5 to 6 years. Earlier they used to use CATIA only, right? And the components they were doing, and there were so many other factors like uh, cost factor in terms of tool will decide which tool to use, or that sometimes the client requirement as well. Okay. we have these two tools in design. Whereas in analysis, for each kind, we have different types. So you can see ANSYS Workbench will give correct and accurate results in terms of assembly of static components. Static components, why we will do? Why we will do static components? To know the strength, durability, fatigue, and fracture, and also transient analysis also we can do in workbench. That is ANSYS Workbench will give a vast exposure of different kinds of analysis on one platform. Then coming to Hypermesh, it is used majorly for meshing complex complete car structure or OptiStrut simulation. You can see OptiStrut means as we are having this, like cars may change, car shape may change, we have to optimize this without changing the mesh count or without changing the loads or mesh. So that is why we will go for Hypermesh, where we can do these kind of different shapes optimization directly in OptiStrut. Okay, compared to ANSYS, this is more it will more give accurate and also easy in the analysis. This in these kinds will be doing in Hypermesh in the industries I'm talking about. You can see according to the part, according to the analysis what we are doing, the tools are deciding in the industries, actual industries. Then ANSYS Fluent is used to know the efficiency or aerodynamics. So where the lift, drag, and downward force, all these things are there. So all this, that means the formulation for each type of analysis is different, and each condition is different. We will be using different types of softwares based on the need and based on the requirement of the analysis and outputs of the analysis. Okay. This flow we can't do either in direct ANSYS static analysis or in Hypermesh. We have to go for Fluent, where that related theory and formulation are embedded in the tool for the calculation of these loads flow. Then LS-DYNA or PAM crash are used for crash analysis. You can see different types of crash analysis we can see here. So it is touching on a pole, or if it is touching a divider, that means we can say that before analysis, whatever we have, all those belongs to static condition. Static condition is that doesn't depend on the time, whereas that is called implicit analysis, whereas whatever we are depends on the time, that is here it is called as explicit analysis. For explicit analysis, most widely used system is LS-DYNA or PAM crash. Observe one thing, these are the simulation tools. To do meshing, again we will be using Hypermesh only, either to run the model in LS-DYNA or both in PAM. Okay, so meshing will be done in Hypermesh, bringing those parameters or factors, do it in again this simulation in this explicit softwares. Explicit softwares are purely of time dependent. For example, you can see until the car touches the pole, there won't be any variation in the car. In fraction of seconds, the car will fail so much and airbag is getting released. So that means in fraction of seconds, it varies a lot. So that's why this comes under what? Performance safety type of analysis, where we are doing this kind of impact or crash. Okay, so is it clear? These are different types of analysis and different components which we will be design and simulating, where it depends on the company standards and also the vastness availability on the tool or the facilities available in the tool to explore in that. So you can see we have discussed about so many components and different types of analysis. For one car, if you take one vehicle, how many parts we'll have? If we take for minimum to minimum, if we take around 1000 or 1500 parts, how many vehicle models are there? How many things are there? Then you can see that how much expansion we will be having or how much job opportunities we will be having in automotive industry. Okay, we have a huge job opportunities. First, we have to fix our niche, our interest. You might be having so many doubts like which tool I have to learn first, what I will get from the learn, why I'm not getting job. All this to clear all these confusions only, we are conducting these webinars so that it will give good insights like these many components are there. So mechanical industry, there is a huge requirement of candidates are required and there were huge opportunities you can see. But we have to make industry ready. One drawback in our system is, we'll be focusing completely on BTech education system, like without learning the tools. Then after learning the tools, we don't know how to correlate actual subject to the tools. That is the major drawback we are all facing. To avoid that, whatever we are learning in BTech, everything is linked to the tool. Then only we can improve ourselves if we know the understanding and correlation, how actually it will go into the physics. Okay, am I right? So hope you got a good idea of like choosing your career. If you're choosing in automotive industry, then you have to choose like what are all you can do, like which one. So according to our requirement or our standards, we have to choose our tools. Basically, for an example, how to choose a tool to learn. I am posing the question, how to choose a tool to learn. Can anyone answer? We have about 7 to 8 tools available, majorly used. Even we'll be using so many other tools like project manager or some low end tools, and so many other things are there. But how to choose a tool is a very important thing. So without shy, I have to understand my capacity. I have to understand my capacity. If I am an average guy, I have to go for design tool. If I'm interested towards FEM and I am a little above to the average or average guy, then I have to go for simulation tool. Either you can choose ANSYS or Hypermesh. So the complexity, if you are a thermal guy, then you can go for Fluent or aerodynamics guy. Okay. So if you know about the complexity in the model and how to do the explicit analysis, because explicit analysis takes a very huge time. It is not like simple models what we get in YouTube. Okay, in actual scenarios, each explicit analysis model runtime itself is 30 days. Believe me, it is 30 days with a high-end system of 512 MB RAM. Imagine how complex it is. If we are making small mistake or small mismatch also, how much loss it will create to the company and how much tension we need to face. 30 days on 512 MB system. So we have to be very careful, very accurate enough to do any complex or explicit dynamic analysis. Okay. So this is how you have to choose your tools. So this I have mentioned some of the automotive companies, still so many are there. you can get. Learning is more important in mechanical core subjects majorly. So certifications doesn't give much priority compared to learn. How you are learning much more gives high priority because your skills will be tested in your technical interviews itself. To know about more technical expertise like this, not only this, if you want to know like which industry is better, what FEA does and FEA inside what it is, please subscribe to our YouTube channel. So you will get more technical content from there. And also you can follow us on LinkedIn. I'll mention YouTube link so that you can subscribe and get more content of technical content of it. So Anish is asking one question. Before that, I'm going to give you how you have to prepare for any interviews. 3 elements are used for skill student. First thing is deeply experimental learning on live or live simulation environment we have to feel. Everybody will have a question that how can we get live simulation environments as we are a freshers or if we did not join the company yet. So for this, what I will answer is first we have to understand how the physics are converting into mathematical equation. That means how working of door we are simulating in math by using a tool. So then we can understand by seeing a component, we can understand what are all elements are there. For example, I'm going to give here, if a disc brake is there, we know if we apply brake, it will get compressed and it gets stopped, right? That means we have to, for the compression, we have to apply pressure. Disc brake, if it is running high, we may need to apply temperatures. And for what we have to do, disc brake is connected with nuts and bolts. There we are going to apply boundary condition. Loads are ready, mesh is ready, model is ready, constraints are ready. Then we have to analyze the disc brake and understand how we are simulating in a software with all these types of loading or constraints according to the functionality. Nowhere we are compromising or assuming the functionality things. Then hands-on and do it yourself. Hands-on means you have to you work, take a component and work to it. Then only you will get so many doubts. Even though you are attending any trainings, while attending the training, we may feel it is very easy. Once we start practicing, we'll get tons of questions. For this, it is good to have an industry expert as mentor. So you will give most guidance and which tool, why we are learning, not only how. We always have to question ourselves why and what. How tool will teach you. Why we are learning is always we have to question what we are doing. According to the why, that means according to the functionality, what we are applying as constraints or boundary conditions as loads, it will affect. Always question by seeing a component, why, how, what. If you know the calculator, that is nothing but the tool, you will get it. But why and what is very important. That is what we have to be very careful about doing the things. Okay. So always plan, strategy, have a vision, have a mission, and then work on it. So first find your niche. In that niche, what is your capability? What is where you want to reach? In that, how you are going to plan. This we'll see. Courses we offer belongs to automotive industry. This SolidWorks, Kataya is nothing but design tools. Altair Hypermesh is a meshing tool. And then MATLAB is for coding. If we need to have a research kind of jobs in the field of automotive, we have to write coding for that. And then we are going to use ANSYS Workbench, and ANSYS only, it is a subproduct Fluent. for aerodynamics. Workbench for, I have already mentioned, static, transient, and fatigue fracture. Hypermesh is majorly for crash, impact, sudden dynamics. Design, so it depends on the industry, SolidWorks or CATIA, because in CATIA we have more options for sheet metals, whereas SolidWorks also have options, but CATIA is the oldest tool. The funny part is both SolidWorks and CATIA are provided by Dassault System, both by the same company. Decide what you are having. So prepare, plan your preparation, then determine, discover your potential jobs, and then you prepare. This is a complete cycle which will enhance you, like, to reach toward your goals. First you have to fix what you have to learn. If you have still confusions, you can reach us through email or through contact. I will be providing in chat box in few minutes. Then we will guide you according to your potentials and according to your knowledge, which is the better tool. Forget about the job. Because why I'm saying this, if you know the tool, automatically companies will reach you. So Danish is asking, do your institute provide job assistance? Definitely 100, not even 100, 200%, we are providing job assistance. So now the companies are in that situation, like, so they have so many openings, but not appropriate candidate. So they don't want to train years and years for a candidate. Better self preparation or well preparation before attending any interviews will give good opportunities. I'm just giving my contact details. Just you can reach at this. I'm typing in the chat box, or you can reach for this contact number too. Okay, another question I got is, so we have the e-courses too, which will provide you complete, which was designed by 10 years, 15 years experienced people. So unlike other e-courses, we are providing in the e-course directly, not only the videos, assignments also, so that you will get how much you have understood. Assignment solutions also we are providing in the e-course. Other than that, the more beneficial thing in providing e-course in our institute, taking e-course from our institute, is we are going to provide weekly interactive sessions, unlike just giving and reading by yourself. Okay, we will test you, we will do you. So Naveen is asking, you have mentioned huge opportunities, but how do we get job opportunities as a fresher? Now most of the company look for experience. No, Naveen, we have lots of opportunities, because why this question everybody will ask. Why it is like, if they are asking for a fresher, might be unlike in IT companies, they may come out of the college and learn one of the tool, testing or data sciences or something, and they will keep the certificate and get the job. Whereas in the core jobs, why they will ask experience is, at least basics we should have. Okay, if you are asking for a fresher, they might be not able to understand the free body diagram, understand the concepts of St. Venant's principle or von Mises stress, why we are taking in the failure criteria. At least to get the minimum knowledge of the basics, what are there in the textbooks. In core companies, if you observe, not only in mechanical, if you observe electrical, civil, or any core company, they will ask minimum 1 year of experience, so that at least you will prepare for the basics and minimum tool knowledge you will be having it. That is what we can provide through our, and also nowadays freshers has lots of opportunities with fresher, again in the sense, in the core subject, 0 to 1 year experience or 1 to 2 year experience are called as freshers in core subjects, since our work is directly related to the BTech subjects. Okay. Hope I have given you the answer, Naveen. If you still have any questions, you can ask. Anish, your salary, you are asking about the salary range. Salary range depends on your capability. That means everybody think that mechanical will give less salary. Even IT testing people will get 3.5 or 4 lakh salary as a fresher, even mechanical also. My friends, I will give you best example who are working from 15 years in industry. They are getting about 30 lakh package, which is more than or above average for a IT guy. IT guy generally they need to do always certifications. In core subjects it is not at all required. Once if we have the fundamental knowledge, then that's it. No need to prepare for complete life. Little enhancements we can make, but it is very stressful in IT, because every year you have to spend at least 50,000 to 1 lakh for the certifications, and for to do the certifications for training again you are going to spend 30 to 40 lakh. You can ask any IT guy. This is uh, the routine. This is the routine to say in other sense. Okay. We also provide the services like consultancy, career assistance. We are generally into like so many corporate trainings, faculty or professional development programs, and in whatever way you want, we are providing in all the things. Okay. Our clients, we have internationally clients also. We got tied up with German companies where we are doing consultancy projects, and also collaboration we are doing, like we are going to do carry out the design and simulation, and they are the manufacturers. We have MOU too with the international clients. These are some clients I have mentioned. Still, we are tying up with so many companies, about 10 to 15 companies in this year. It's all in process. Thank you all, guys. Hope you had a great time and got good essence of why to use automotive and in which portion you have to improve your skills. Still, if you have any issues, anytime you can reach Artem Academy to this contact number and the contact address.